Hello and welcome to this video tutorial on Amazon Route 53 routing options. In this demo, I'm going to show you how to accomplish some different types of routing using Route 53. Specifically, I'll demonstrate simple routing, failover routing, and geolocation routing. And for each example, I'll first briefly show a diagram illustrating what I'm going to configure, and then I'll show you how to configure it in the AWS Management Console. And finally, I'll run a quick test in the browser to demonstrate the resulting routing behavior. Okay, let's get started. In this example, I have a registered internet domain named mompopcafe.net that I'm managing with Amazon Route 53. I also have a VPC with two Amazon EC2 instances running in it. Each instance is running a web server with my Mom Pop Cafe website hosted on it. The instances are configured identically, and I want to configure Route 53 so that HTTP requests are distributed evenly in a simple round-robin fashion between these two EC2 instances. To configure this, I'll need to define a Route 53 record set in the mompopcafe.net hosted zone. Now let's take a look at how this setup can be accomplished in the Amazon Management Console. Okay, so here I have three browser tabs all open to different views in the AWS Management Console just to make it easier to show what already exists and is configured in this account. Here in the VPC area, you see public subnets 1 and 2 already exist. They are defined in different availability zones. And here in the EC2 area, you see that two instances of the Mom Pop Cafe server are running, one in each of these subnets, and you can see that they are in different availability zones. Let's just verify that one of these web servers is working and the website is available. I'll just copy the public IP address of the server 1 instance and paste it into another browser tab. I'll add Mom Pop Cafe to the end of the domain name since that is where my web app is running. And here you see the web app is running, which is great. However, keep in mind the objective here. I want end users to be able to find this web page by going to my domain. And not only that, I want to route traffic evenly between this instance and the other one. Notice on this page that it conveniently shows the availability zone of this server, in this case EU West 2A. The other server runs in EU West 2B. I'll need to copy the public IP address of each instance when I configure the Route 53 record set, so I'll leave this view open. Now over here in the Route 53 service dashboard, you can see that I have one registered domain and one hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route 53. You can find unclaimed domain names and purchase and register them through the AWS Management Console, or you can also transfer a domain purchased through another vendor over to Route 53 for management. Once your domain is registered in Route 53, if you click into hosted zones, you will see a hosted zone has been created with your domain name. Clicking into the hosted zone, you see that two record sets already exist because they were created when the domain was registered with Route 53. The NS or name server record lists the four name servers that are the authorized or authoritative name servers for your hosted zone. You should not add, change, or delete name servers from this record. The start of authority or SOA record identifies the base DNS information about the domain. It was also created when the domain was registered with Route 53. But now I need to create a new record to configure the simple routing. So I click Create Record Set, and then I'll give it the name www.mompopcafe.net, and this will add a type A record, which will simply map the DNS name to one or more IP addresses. The time to live, TTL, will be the number of seconds that DNS resolvers should cache information about this record. For the purposes of this demo, I'll make it very short, 15 seconds. Now the value is where I need to paste the public IP addresses of the two running servers. So I'll go back to the EC2 page here and copy the first one and then return to the Route 53 page and paste it in there. And now I'll copy the second one as well and paste that in as well. And now we get to the routing policy. From the drop-down menu, I'll choose Simple, which happens to be the default, and that's it. Click Create to save the record set. Now let's test this configuration. I'll open a new browser tab and load the URL www.mompopcafe.net/mompopcafe. And here we see one of the two instances page loads. In this case, it's EU West 2A. And now I'll load the page a few more times, and you'll see that the same URL takes me to one of the two instances. Since I specified multiple values in the record, in this case, two IP address values, Route 53 returns these two values to the recursive resolver in random order, and the resolver returns the values to my web browser that submitted the DNS query. So as you see, HTTP requests to my domain name are being routed between the two instances I specified in the record set. This concludes the simple routing part of the demo. In this failover routing example, I have a registered internet domain named mompopcafe.net, and I'm managing it with Amazon Route53. Just as in the last demo, I have a VPC with two subnets in it. The subnets are in different availability zones. Each subnet has an EC2 instance running in it. And each instance is running a web server with my Mom and Pop Cafe website hosted on it. The instances are configured identically, and I want to configure Amazon Route53 so that one of these instances, the one in availability zone 1, is the primary server that will service all HTTP requests. However, if the primary goes down for any reason, I want the instance running in availability zone 2 to take over the handling of the HTTP requests so that users won't even notice that my primary web server went down. So how can I configure this? I'll first need to define a Route53 health check that monitors the status of the primary web server instance. If the health check determines that the primary instance is unreachable, then the record set I define in the mompopcafe.net hosted zone will route traffic to the second instance instead. The Route53 health check will also send an alert to my administrator team to inform us about the unreachable instance. So now that we understand the design, let's take a look at how this setup can be accomplished in the AWS Management Console. Okay, so here we have, again, 3 browsers all open to different views in the AWS Management Console, just to make it easier to show what already exists and what is configured in this account. Here in the VPC area, you see public subnets 1 and 2 already exist. And here in the EC2 area, you see that 2 instances of the Mom Pop Cafe server are running, 1 in each of these subnets. And you can see that they are in different availability zones. Let's verify that the primary web server is working and the website is available. So I'll copy the public IP address of the server 1 instance and paste it into another browser tab. And I'll add Mom Pop Cafe to the end of the domain name, since that's where my web app is running. And here you see the web app is running. Notice on this page that it shows the availability zone of this server. The primary runs in EU West 2A and the backup web server runs in EU West 2B. I'll need to copy the public IP address of each instance when I configure the Route53 record sets. So I'll leave this view open. Now over here in the Route53 service dashboard, you can see that I have 1 registered domain and 1 hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route53. And if I click into the hosted zones and then click on the mompopcafe.net hosted zone, you see that 2 record sets already exist because they were created when the domain was registered with Route53. As in the last demo, I'll leave the NS and SOA records alone. The first thing I want to do is define a health check. So I go to Health Checks and click Create Health Check. I'll name it London Website Status. What to monitor is an endpoint, and I'll specify the endpoint by IP address. So I'll need to paste in the public IP of the primary web server running in EU West 2A. I'll just go back over to the EC2 page view and copy that value, and then return to the Route53 page and paste that in here. The port number is 80, the standard HTTP port. And for the path, I'll add Mom Pop Cafe since that is the URL that loads the web application. Let's expand the advanced configuration area, and since this is a demo, I'll set the request interval to a short period of 10 seconds. I'll also set the failure threshold, which is the number of health checks that need to fail before the health check status turns unhealthy. I'll set that to 2. Then I'll leave the other settings as they are and click Next. And finally, create alarm yes. So now we go down to the notification configuration screen, and I'll define an SNS topic, website down. And I'll enter my email address. Finally, I click Create Health Check, and there you see that the health check is now defined. It will initially have a status of unknown. However, this should be resolved within a few seconds. If I click Refresh, let's see if the status is updated. Yes, there it is now healthy, which means the health check has verified that it can hit the URL that I defined in the settings, and the web server is responding with an HTTP status code of 200. One quick thing to do at this point is to check your email and look for the subscription confirmation email you should receive. Click on the Confirm Subscription link in it, which should open a browser page indicating that your subscription is confirmed. Okay, so now that I have a health check configured, let's move on to configuring the failover routing that will be triggered whenever the health check returns an unhealthy status. I click over to hosted zones and then click on the registered domain. And now I'll click create record set. I'll make the time to live very short, 15 seconds. And now the value is where I need to go back to EC2 page and copy that public IP address from the primary server. And now we get to the routing policy. So from the drop-down menu, I'll choose failover. The failover record type is primary, since this is the IP of the primary server. Is this associated with a health check? Definitely. So I choose yes, and then from the drop-down menu, choose the health check I just defined a moment ago. And finally, I click create to save the record set. Now I need to define another record for the secondary web server. I'll give it the same name and 15 seconds for the TTL. For the value, I'll copy the public IP of the second web server. So go back to the EC2 tab, copy that, paste it in here. And the routing policy is again failover, but this time the failover record type is secondary. And the record set does not need a health check associated with it because it's the backup. So I'll just go ahead and click create. And so, okay, now there are 4 record sets in this hosted zone. The 2 A-type record sets are the ones I just defined. The first is the primary failover record set that has a health check associated with it, and the second is the secondary failover record set. So now let's test this configuration. I'll open a new browser tab and load the URL. And here we see that the primary web server, the one in EU West 2A, is the one that loads. That is as expected. And now we want to simulate an issue with the first web server. So I'll go over here to the EC2 page and stop the primary instance, which should cause the health check status to change. Let's return to the tab where I have the web page loaded and try refreshing the page. Notice the site is temporarily down. Now let's look at the status of the Route53 health check to see if it's noticing that there's an issue. If it does not already indicate an unhealthy status, give it a few seconds to notice that the website is no longer responding. Okay, it's been about 20 seconds, so now notice it is unhealthy. I'll load the page again, and there we go. The primary server is still down, but the website is responsive again. So as you can see, the failover routing is working. The website was only unresponsive for a few seconds. Specifically, it was unresponsive during the time it took for the health check to fail given the health check interval of 10 seconds that I defined and the number of consecutive health check failures that I defined as a threshold, which was 2. So after 10 times 2, 20 seconds, the failover routing rules kicked in and the HTTP requests to my domain name are now being routed to the secondary instance that I specified. As a final step, I'll check my email and see if I received a notification. And yes, there it is, the email triggered by the health check and sent by the simple notification service informing me that one of my web servers did not pass the health check has arrived in my inbox. This concludes the failover routing part of this demo. In this third and final part of the Route53 routing demo, I'll demonstrate how to configure geolocation routing. Geolocation routing lets you choose the resources that serve your traffic based on the geographic location of your users. In other words, the location that DNS queries originate from. In the routing solution I will demonstrate here, all users in Europe who load the Mom Pop Cafe website URL in their browser will be routed to the website instance running in the EU West 2 London region. And all users in North America who load the same Mom Pop Cafe website URL in their browser will be routed to the website instance running in the US East 1 Virginia region. This will allow us to localize the content. For example, the currency will display in British pounds on the London website and in US dollars on the Virginia site. So now that we understand the design, let's take a look at how this setup can be accomplished in the AWS Management Console. So here we are looking at the EC2 Management Console in the London data center, and you see that an instance of the Mom Pop Cafe server is running. Let's verify that the web server is working and the website is available. I'll copy the public IP address of the server instance and paste it into another browser tab. And I'll add Mom Pop Cafe to the end of the domain name since that is where the web app is running. And you can see that the web app is running. Notice on this page that it shows the availability zone of this server, indicating EU West 2A. That also obviously indicates the region, which is EU West 2, London. Now let's take a look at the Virginia region. Notice that there is also an instance of the Mom Pop Cafe server running here. Let's copy the public IP and verify the web server is running. It is. And this instance of the web server also displays the region. Now over here in Route 53, in the service dashboard, you can see that I have one registered domain and one hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route 53. And if I click into hosted zones and then click on the mompopcafe.net hosted zone, you see there are already two record sets that exist because they were created when the domain was registered. And as in the last demo, I'll leave the NS and SOA records alone. And now I'll need to create two new record sets, one for each region I want to route users towards. I'll click Create Record Set to start creating the first one. I give it the name www, and it'll be an A type record. And I'll make the time to live very short, 15 seconds. For the value, I need to grab the London web server's public IP address and paste that in there. So I go back to the EC2 page, showing the London resources, copy that, return to the Route 53 page and paste it in there. For the routing policy, I'll choose geolocation. Now here's where it gets interesting. I need to choose a geographic location. I can choose a continent or a country. For our purposes, I'll choose Europe. And for set ID, let's type in something descriptive like Europe-London, since we are routing all Europe traffic to an instance running in London. There is no health check to associate, so just click Create. And now I'll create the second record set. For the value, I need the Virginia web server's public IP address, and I'll paste that in there. And for the routing policy, again, geolocation. And the location, I'll choose North America. For set ID, let's type in something that matches the format we used before on the other record set. So I'll type North Amer-Virginia, and I click Create. Okay, so now there are 4 record sets in this hosted zone. The 2 A-type record sets are the ones I just defined. The first routes users in Europe to the London EC2 instance, and the second routes users in North America to the Virginia EC2 instance. Now let's test the configuration. For this demo, in order to emulate me being in different geographic locations, I've spun up 2 Windows instances. One is in California and the other one is in Paris. I'll first establish a remote desktop connection to the one in California. And now I'll open a web browser on this instance and pull up the mompopcafe.net site. And you see that I was routed to the Virginia instance, as we would expect. Let's look at the menu page and confirm the currency is in US dollars. And there you see it is. Now I'll establish a remote desktop connection to the one in Paris, France. Now that I'm connected, I'll open a web browser on this instance and pull up the mompopcafe.net site from here. And here you see I was routed to the London instance, again, as we would expect. Let's look at the menu page and confirm the currency is in British pounds. It is. Maybe I'm a resident of London, but I'm away on a short business trip to Paris and I want to order some dessert that I can pick up when I get back in town. And there you have it. We have seen how the geolocation routing feature of Route 53 can be configured to route users to an instance in a specific region based on where on the globe the users are located. This concludes the geolocation routing part.